Hello, welcome back. As usual, I have to set the stopwatch so that I don't make the video that long. Yeah, okay. Well, we are now looking at, this is the most interesting part of differential equations at A level. Oh, by the way, my name is Saleh Mohana. I have taught A level maths for over 50 years, and I'm just recording these lessons to help you revise and go over what you have been taught in school and prepare yourself for the exams, if you wish to, of course. And I'm almost toward the end of the marathon. That's almost 150, more than 150 videos. Just I thought I should share whatever I know with you. That's all. So now, as we did when we did maximum minimum, you read the question carefully, identify the variables, write down the differential equation, use the conditions, solve it. So let's read. The rate at which a radioactive substance disintegrates, so it's going to become less, is proportional to its mass m at time t. Proportional to its mass m at time t. So you've been given the variables. M is the mass, t is the time, the rate would be dm by dt. Oh, the pen has given up. Okay. dm by dt is proportional to m, or dm by dt equals km. You can as well use minus km, it does not make it. In fact, you should use minus km, but let me stick to km, doesn't matter. So first job will be solve. So 1 over m dm equals k dt, integrate both sides. That gives me ln m equals kt plus ln a. Remember, I told you if you have the dependent variable as a log function, call the constant of integration as ln a, it makes life easier. So ln m minus ln a equals kt. That gives you ln m over a equals kt. That gives you m over a equals e power kt, or m equal to a e power kt. So from the first relation, I can get the solution m equals a e power kt. That's the solution. In fact, that's a standard solution. You get about 3 marks to do that at best. Nothing more. I want to rub this off because I want to read the question and analyze and take you through it. So now next bit will be, the question didn't have a k. We brought it, or you brought it, or I brought it because of proportionality. The question didn't have an a. I brought it. When you are solving a question, you will bring it. That's a constant because of integration. And the fundamental rule is, any constants and unknowns you bring, it's your job to evaluate, or in this case, my job to evaluate. So let's do that. That means I have 2 unknowns. I require 2 pieces of information. I have initially the mass is m naught. So t equal to 0, m equals m naught. And t equal to, after 20 years, it has lost 10% of its original mass. Remember, m is a mass remaining at time t. So at the end of 20 years, 90% is left, which is 0.9, which is 0.9 m naught. So if I substitute there, remember m equal to a e power kt. So m naught equal to a e power 0, which gives you a equals m naught. So as you find an unknown, put it into the question. So m equal to m naught e to the power kt. So if I use this, I get 0.9 m naught is equal to m naught e to the power 20k. So e power 20k equals 0.9, 20K equals ln 0.9, which gives you K equal to 1 over 20 ln 0.9. So let's find the answer for that. Yeah, I better wear my glasses because when I did this question before, I committed a blunder. So let me wear the glasses. I didn't read it properly. ln 0.9 divided by 20. 0.00527 minus 0.00527. However, I prefer using a minus, which I will do when I do the next question, because if some quantity is reducing, put a minus. If the quantity is increasing, put a plus. That way you avoid the negative sign here in copying. So therefore, your final solution is m equal to m naught e to the power minus 0.00527 t. Remember, when you finish solving, you should have only two unknowns, m and t. But sir, there is an unknown m naught. M naught is not an unknown. It's a value given to you. Now he says, what percentage of original mass will remain after 80 years? So we want to find t equal to 80, m equals what? So m equal to m naught e to the power minus 0.00527 times 80. Let's find that. I need to use my calculator. Minus 0.00527 times 80 is that shift ln answer equals 65.59, 0.6559 m naught, approximately 0.66 m naught, or 66% remaining. Which makes more sense. You know, funny, when I did this question first, I normally make up these questions. I solve them to make sure they make sense before I solve it on board here for you. What I did was, for some reason, I took it as 0.0527 or 0.000527. As a result, I think 0.000 instead of 00. I ended up getting it lost 10%, and here 94% was remaining. That means first it lost 20%, and then at the end of 80 years, it was 96% remained, lost 4%. In other words, instead of decaying, the radioactive substance was gaining mass, which is ridiculous. Anyway, so that was one question. Let's look at the next question. This is a very interesting question. This is from an old textbook which I used way back in 1970s. I think 78, 79. You're being told that a solution contains 1,000 liters of water and 10 kg of salt dissolved in it. Why? I thought I could always write it and then call you back. But by reading, while writing, you will hear, you will see. That saves me time of reading the question again. Okay? And saves time for our technicians and our engineers to scissor and paste. Okay. Every minute, 20 liters of water are added and 20 liters of the solution are drained out. That means, you pour water from the top, 20 liters, and you remove solution from the bottom. If, of course, they mention the solution is kept consistent by constant stirring. Okay. How much salt is left after 20 minutes? Oh, sorry, after 5 minutes. Then the salt needs to be topped up when it falls down to 5 kg. Find to the nearest minute the time to top up. That's a beautiful question. I enjoy doing this question because it's pretty interesting actually. Let me turn on the stopwatch to make sure. I mean, it's running, but I have to keep an eye on the clock. It's 12 minutes, so it's okay. See, this is again a very clever question. It looks very simple, but it's not as simple as it looks. So, what happens is, remember, you're putting 20 liters of water and you're removing 20 liters of mixture. So, that being the case, every time you're removing some salt, replacing it by water, removing some salt, replacing it by water. But you see, because the solution is getting diluted because removing the salt, the concentration starts reducing. So, in other words, the amount of salt in the solution keeps changing, keeps reducing. So, that's the first variable. So, we assume let x kg salt remain after t minutes. So, you have identified the variables. Now, what do you mean by concentration? When you remove 20 liters of solution, the solution contains x kilograms of salt dissolved in 10,000 liters. So look, that means x kg salt in 10,000 liters. Oh, 1,000 liters. So what's the concentration? So concentration is x over 1,000 kg per liter. You understand that? So, the concentration is amount of salt per liter. You are removing 20 liters removed, which would mean 1 liter x over 1,000, 2 liters 2x over 1,000, 20 liters 20x over 1,000 kg removed per minute. This is how the salt is reducing. So the rate of change of salt is minus x over 50. That was the differential equation you had to make. So our differential equation now is dx by dt is minus x over 50. That was why all that information was given. See, since the volume doesn't change, it's safer. But I hope there was a question, I remember when 25 liters of water are added, 20 liters are removed. So every time the volume is increasing. So I think it will be after t minutes, every minute you got 5 liters of 5t extra water. So it will be 10,000 plus 5t x over 1000 plus 5t. But fortunately, they made life easier because the amount of water has remained the same. So you're only worried about the mass of salt. Very good. Now let's put the initial condition that I've been given. You understand how to build the differential equation. Very good. Now you've been told t equal to 0, x equal to 10, t equal to 5, x equal to 1. And then x equal to 5, t equal to what? That's your question. How much salt is remaining after 5 minutes? Alright? How do you solve this differential equation? So 1 over x dx is equal to minus 1 over 50 dt. Integrate ln x equal to minus t over 50 plus ln c. So ln x over c equals minus t over 50, x equal to c power minus t over 50. Remember I told you, any constant you bring, it's your job to evaluate. So t equal to 0, x equal to 10. So 10 is equal to c e power 0. So therefore, c is equal to 10. So your final solution becomes x equal to 10 e to the power minus t over 50. Remember I told you, in the end, when you solve, you must have only two unknowns. I have an unknown x and I have an unknown t. Alright? So, now, let's go further. You're being given t equal to 5, x is equal to 10, e power minus 1 over 10. How much is that? 10 times shift ln e power minus 0.1. 9.05. So after 5 minutes, you've almost removed 1 kilo. So common sense tells you, okay, so 1 kilo, so you want 5 kilos out. So about 45 minutes. Think carefully. Now put x equal to 5. So I get 5 equal to 10 e to the power minus t over 50. So e power minus t over 50 is equal to half. So minus t over 50 equals ln half. So t equal to minus 50 ln 0.5. Let's do that. Minus 50 ln 0.5. Minus 50 times ln 0.5. 34.65. T is 34.65. So approximately 35 minutes. Not 45 or 50 minutes as 25 minutes as we said, because as more water comes in, the solution is going to become thinner or concentration is less. So even if you remove 20 liters, as you progress, the amount of salt you're removing is less. So if you're doing a degree in chemistry or doing a degree in chemical engineering, a situation like this will become useful. Okay, so I'll stop at this. The next lesson is very interesting because I'm going to talk to you about Newton's law of cooling and do a couple of questions which make life very interesting. I'll see you in the next lesson. Bye bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.